transport systems. Let me end this. Stop sharing. And then I share this instead. Okay. Let me get this off before it starts disrupting the whole thing. Okay, so today's lecture is going to be quite short. I will do an introduction of what we are supposed to do in this course. So there will be an introduction where we define the intelligent transport systems, and then we look at the basic elements of an automatic control systems and some emerging vehicle automation and communication systems. That is what we are going to do. That's the introduction part for today. And then after that, there's going to be an assignment where you will research or you do some work on the automation and communication systems which are in vehicles. In the subsequent lectures, this one, I think when we're doing the traffic flow modeling course, I mentioned that automatic data collection methods is also part of the intelligent transport system course. And I said, if you remember, that I was going to give it to you as an assignment. So here there's going to be groups where you do further research on. I presented some method in the traffic flow modeling course. So here, you guys are supposed to do some research and then make some presentation on this topic. And then later in the course, we'll look at advanced traffic information systems, or what we call the real-time traffic information, where we will look at traffic information from different media like the radio, television, smartphones, navigators in our vehicles, internet services, and then the variable speed limit systems or the variable message signs. We will look into detail. We'll spend much time in this area looking at the different mechanisms for transmitting traffic information, which is a form of managing traffic. And then after this, we also moved into the quality of the information which has been used that is the traffic information. What is the quality of the information which has been provided? How do we measure this? If, let's say, you get traffic information from Google Live traffic, how do you measure the quality of this information? Is it reliable? I mean, how do you assess that? We will also go into that. And then again, we'll look at some dynamic methods for traffic management. And here we will look at ramp metering, where we will look into some control strategies for the ramp metering. Here we'll do Ancona and then a linear, which are all ramp metering control strategies. And then we look still under the dynamic traffic management. We will look into hard shoulder running, reversible lanes, and then high occupancy vehicle lanes. And then there's also the high occupancy towed lanes, which is different from the high occupancy lanes. And then the last one, which is also going to be in the form of an assignment, where you do the assignment and then you come up and make presentation on what you've done, is intelligent tolling and parking control systems. So basically, this is the course structure. This is what we are going to do in the next 2 weeks. And we hope we will enjoy it. Please, if anyone has any thing to say on what we are going to do, please let me know. I will be mentioning names. I've learned that people log in, go and sleep, or they just log in for you to know that indeed they are online, but usually they may not be behind their computers. So from time to time, I will mention the names of people to make comments. Please, if you are not talking, just mute yourself. And then when I ask you to talk, you unmute yourself in order not to disrupt the lectures. Okay. So if anyone has any comments on the course structure, what we are supposed to do.
Yes, sir.
Yes, let me hear you.
Yes, concerning the evaluation, you just mentioned assignment and you depicted group assignment. Will everything be group assignment or individual assignments will also be included?
Okay, so we're going to have groups presentations. You do the assignments, you present, and then there will be individual assignments. The one that we are going to have today, for instance, is individual assignments where you do and then you submit.
Okay, thank you, sir.
Welcome. Yes, any more?
Hello, Doc.
Okay. Yes, please.
Doc, please, the time you were talking about the first assignment.
Yes.
My system got off, so I just joined back.
Okay, don't worry. As I go along, I will ask you, I will show you what you are supposed to do. Okay. And then you do and then submit.
Okay, Doc, thank you.
Okay. But from time to time, I will be giving you literature. When I sent out the course material, I also included a paper which you are supposed to read before we do the lecture on the Advanced Traffic Information System. So please try, do it, read it before we do the next lecture. So there will be an assignment today, then read the document I provided before we do the next lecture. That will make things easy. Okay. So by way of introduction, we all know, let me try and deal with this before I'm having so many. Okay. Traffic control started in the 1960s. Usually they were manual forms of data gathering, as we do here when we are doing traffic data collection. You go stand by the roadside, use some forms to gather the data. But these have undergone various forms of automation. Currently, if you are doing any form of data collection and you want to rely solely on manual forms, you may not be taken seriously. The increasing complexity of traffic congestion and its continuous change of traffic characteristics, such as flow and speed. You know, traffic is dynamic. And so because of this nature, it has become necessary that we use dynamic methods to solve the constantly varying traffic problem. This is very, very important because if you are using, let's say, phased traffic light system, the traffic condition may change. And if you are using that all the time throughout the day, it may not be very much useful. So it has become necessary that you use dynamic methods in changing, in taking decisions when it comes to traffic. So ICT, we know, has taken the world since the 1990s by surprise. Things are moving very, very fast. And it has also affected happenings in the area of traffic engineering. With the revolution of ICT since the 1990s, the pace in the implementation of dynamic traffic management has gained momentum. Initially, I think when we're doing the traffic flow modeling course, I mentioned that automatic forms of traffic data collection started in the early 1960s in Germany, when they thought that they could use automatic methods to measure traffic data collection. So what they did was that, so let's say you have a road network. Let me erase this. Okay. So you have a road network. I want to show this on your screen. So you have a road network here. You have this road, and then you have an inductive loop detector. They installed inductive loop detectors. Okay, so let's say you have this, an inductive loop detector, and this is the travel direction, right? This is the travel direction, okay. So they started with single loop detectors where they used to indicate, to count vehicles. So here you have an inductive loop detector installed within the road network to count vehicles. And then people came up with an idea of using dual inductive loop detectors. So instead of just one detector, you have another one, let's say here. So you have two detectors. And then with this and this, when the vehicle enters here, the time it enters here is recorded. It gets to this point, it's also recorded. The distance between the two detectors is known. And so you can also use this to do speed and then also some vehicle classification. So this method started in the 1960s. And then by 1990s, when the ICT became revolutionized, it gained momentum. And so now there are several methods of using to in the area of intelligent transport systems. So intelligent transport systems has provided an avenue and is viewed as an essential component for present-day traffic management. So if you want to do any serious traffic management, you need to take intelligent transport system seriously. You need to seriously take intelligent transport systems if you want to do any serious traffic management. Okay. Please, if you have any question, you can just go ahead. Either you go to the chat room and then you put your question there, or you can raise your hand, or you can just unmute yourself and then ask the question. I mean, that's okay with me. Okay. This, I will not waste time on it. So what is intelligent transport systems? So intelligent transport system is concerned with the application of electronic information and control in increasing safety. And then look at the keywords. You are using or you are applying electronic information and control in increasing safety and dealing with the growing emission and congestion problems. So you use electronic information and control, and this can be outside of the vehicle or in the vehicle to increase traffic safety and then dealing with the growing emissions and then the congestion problems I didn't go over this, but we are all aware of what congestion causes. Delay air pollution, noise, it degrades the infrastructure, it can frustrate the road user, which also has its health issues, and of course, road traffic crashes. This, I think we've covered this under the traffic flow modeling course. So, yes. So the aim of using ITS in the area of transport is to increase safety of road users, and then and also deal with the growing emission and the congestion problems. So this is what intelligent transport system is and what it aims to do. Okay. Ambassador, are you around?
Yes, I'm always around. You know, I don't make class.
Okay, that's fine.
I'm just decided to be quiet for some time.
Okay. Abraham.
Okay.
Abraham.
Okay.
Abraham, I can't hear you very well. Please speak louder.
Okay. Yeah. Yes, please. I'm around.
You're around there. Okay.
Yes, please.
That's fine. Okay. Is Kwaku around? Solomon Aye? I can't see him. Please, Solomon Aye, Kwaku, please, are you around?
Yes, I'm around.
Oh, okay.
Around.
That's fine.
Hello.
Yes.
Hello.
Yeah, Kwaku, I can hear you. Okay, let's continue. Ejara. Oh, Ejara is sleeping.
No, sir.
Okay, that's fine. Okay. Let's go ahead with the.
Hello.
Yes, do you have a question? Let me hear you. Okay, so I'll go ahead. If let's say my network goes off, please somebody should the class president should give me a call, because maybe I may not be aware that my system has gone off. So if you can't hear me clearly, please give me a call, and then those of you with my numbers, you can draw my attention to that, and then yeah.
Okay, no.
Okay, so still with the definition of what intelligent transport system is, so it may be used on information supplied within the vehicle. Yes, so usually it may be within the vehicle or by traffic management centers, which we will see some examples here. And so it's either in the vehicle or by traffic management centers and applied to the vehicle and then the user. Or it may be integrated into the transport infrastructure. So here, the intelligent transport system may be within the vehicle or by traffic management centers and applied to the vehicle and users, or it may be built into the transportation infrastructure. Okay, so let me ask at this point, what are some of the systems, intelligent transport systems, which may be within the vehicle? Within the vehicle. Anybody can go ahead and then tell me. I don't want to mention names. Yeah. Systems which may be within the vehicle, which may help us to improve safety.
Yes.
Radio detector.
Radio what?
GPS. Radio detector, a GPS.
Okay, what would that do?
It measures the speed.
Okay. So this will be to measure the speed. Actually, this is not exactly what I wanted Things within the vehicle
Hello,
which
sir.
can help us to improve safety, for instance.
Yes, can I come in?
Yes.
Have a Chinese meter.
Sorry?
Some vehicle have Chinese meter on it. Where when you
Teenage.
meter.
Oh, okay. To measure what? The kilometers you've traveled?
Exactly.
Okay. So things within the vehicle which can help us to improve safety. Who is Bella? Bella, please use your real name, your full name, so that. Yes, things within the vehicle which could help us to improve safety, please. Gloria.
To improve safety,
Yes,
the navigation system of the vehicle,
would help us improve safety.
showing you where to go. Sorry.
It's like all of you are looking
Pardon?
at one direction. Isaiah.
Hello. Hello.
Yes, Isaiah, I'm listening.
Yes, I was also going to mention the GPS.
The GPS. Okay, so things within the vehicle, things concerning the vehicle. We are saying that intelligent transport systems may help us, or is based on information supplied within the vehicle or by traffic management centers and applied to the vehicle and user. So I want things within the vehicle. I mean, yes.
Sir,
Can we use the
sir,
speedometer?
the braking pad.
The braking pad.
What about the speedometer?
The paddle.
Proximity sensors, and then the cameras.
Yes, yes. Those are things which can help us to improve safety.
Please, how about the
Airbags, for instance. You know, there are several technologies going on within the vehicle which could help us to improve safety. And right, so the cameras, for instance, could help us. Some vehicles can give you advanced warning signs, some sensors to tell you that you are approaching this or you are at this distance from the next vehicle, and so you get some warnings. So these are things within the vehicle. I understand where you guys are coming from, because mostly we are civil engineers, and so we are more concerned with the traffic and then the road infrastructure. So we look at ITS just within that context. But alcohol interlock system, for instance, which will prevent people from getting into their vehicles when they are drunk, are all systems which would help us to improve. And these are all intelligent transport systems, but basically things within the vehicles to help us improve safety. So we will look at some of these things. This is what we are going to do basically today. But so it may be based on information supplied within the vehicle or by traffic management centers. So the vehicle is also important, but I agree with you that as traffic engineers, usually we may not be looking at it. But as you buy these new vehicles, for instance, you see some technologies which are all aimed at improving safety, even in the case of crash, or to prevent the vehicle or the road user from getting into any dangerous situation which may result in crashes. So all these are intelligent transport systems. Okay.
Doc,
yes, please.
Doc, how about vehicle trackers? Those that are when your vehicle is confiscated, then you are able to track and get it.
Well, these are all intelligent systems, but so this one is purely for security, right?
Yes, please.
The security of your vehicle.
Yeah.
Okay. Yeah. But I understand most of us are concerned, and even as we are going to do in this course, we may not get into details, things within the vehicle, because that is not my area, that is not your area, but we'll be looking at traffic management systems and then things which will help the road user, and then of course the road infrastructure. So ITS systems which will be integrated into the road infrastructure to help us improve safety and to reduce emission and increase traffic flow. That is what we are going to concentrate on. Okay. So we have some basic elements of automatic control systems. This is very, very important. If you have any automatic control systems, and as I said, we are coming back to the road, our area, and you have here disturbances. So you have, as we did in the traffic flow modeling, we learned of lane changing processes, car following models. So as these processes goes on within the road network, it creates some disturbances, right? So here, and that is what we term as the process. So the lane changing, the overtaking, the car following, whatever. This is what is termed as the process, right? So what we try to do is to measure the process. And how do we do that? How do we measure the process? Here we do by using sensors. So you can use inductive loop detectors, you can use all the sensors that we talked about, right? Bluetooth method, which has been used to also measure the traffic situation. All these sensors are used to measure the process. So when you measure the process from here, and then this is what you see in the real world situation. Let me indicate this here. So here, this line. Yes. Up here is what you see with your eyes. Below this, you don't see anything. It's what goes on behind the scenes, right? So the processes, the car following, the lane changes, which is the process, and there is the need to measure the process. And here you use sensors to measure the process. Okay. When the measurement is done, this data is transmitted to a control center. So the collected data, which is measured by the sensors, is transmitted to a data processing center where you have a strategy. You have a strategy to control the traffic, right? So when the strategy is selected, then you show that strategy again. So here you are moving from what you don't see, what goes on behind the scene, to the real world situation, and then show whatever information based on the data that you've collected to the road users via actuators. So if you have traffic lights, for instance, you may have a traffic lights, a green or red displayed on the actuator, or you have a variable message signs, the speed, which will also look at it in detail. The speed will be displayed on the gantries. So whatever is measured here, there is a control process, and then the appropriate strategy is selected and displayed to road users via actuators. So this is the component of automatic control system, where you have the processes, the disturbances. You measure them using sensors, and then the sensors transmit the data to a data processing center where the data is processed And then based on the condition, a control strategy is selected and then displayed to other road users via actuators. So this is the component of any automatic control system. As we go ahead in the course, we will be able to see some specific. We will look at the control strategies for real-time traffic information, for instance, and then the variable speed limit systems. So we'll go into that in details, but this is the basic element. First, the process is there, the sensors are used to measure, the data is processed, and then when the data is processed, the appropriate control strategy is selected, and then that is transmitted to, or it is shown to the user via actuators. Okay. So
yes,
here, yes.
Yes, I was looking at the control strategy.
Yes.
I was thinking what is displayed on the actuators should be the output, which is available to the users.
Exactly.
But I'm seeing inputs here, I don't know. I'm seeing inputs going into the actuator.
Input on the actuator.
Oh, okay, okay.
Yeah, that's the explanation here. Input on the actuator.
And then the actuator will display it as output.
Yes.
Oh, okay. Okay, thank you.
As we go into specifics, we'll be able to appreciate whatever is going on within it. We will look at the various methods, how the process actually takes place in doing some of these things, and we'll appreciate it the more. Okay, so we have the technology, which may include the sensors. The whole of this may be grouped into two. So you have the technology, sensors, communications, the computing, the actuators. That is the technology, right? And then you have whatever goes on within, outside the scene. That is the methodology, the data processing and which control strategy you should use. That is the intelligence. So you have the skeleton, which is this, and then the intelligence. When, as we see along, if we detect an appropriate control, if you detect a problem, the appropriate control strategy should be displayed. And so your intelligence must also be correct, because you can detect a problem and then display a wrong solution to whatever problem that you've detected. So that is also possible. But this is the basic element for this.
Hello.
So the process is a conventional vehicle flow, the sensors. You can have examples to be the loops, the radar, the Bluetooth, magnetometers, and so on. This is what we are going to do as an assignment. And then the communications, how the data is transmitted from one point to the other. And formerly, people was using the wired system, and then the conventional FM radio broadcast came in, or what we call the TMC, which will also look at the traffic message channels. And then now what is being implemented, that's the digital audio broadcasting, which we will also look at. Then the computing is what you have, the central and then the decentralized. You can have a central system, or you can have a decentralized system where sub-components of the system is analyzed before it's sent to the center. And then the actuators, usually by the roadside, to display to the road user the traffic systems. You can have ramp matrons, which will also look at the variable speed limits or the variable message signs. This may be displayed on the actuators. So this is the processes which must go through basically with the traffic management systems. Any questions?
Hello, Doc.
Yes, please. You are. It's just like you are far away. Please speak louder. I can't hear you very well.
Are you getting me now?
Yes, better.
Okay, I'm discussing the control system that we're looking at that too long. Can you please go back, Esla?
Okay.
Yeah, okay. Looking at the control strategy that we have here. After a been process, it goes into the actuator as input. But then I'm seeing that we still have the process here, but then we have the output. I'm still not understanding it.
So it's more of, usually it's more of what we call the closed system, right? You take data from the system and then display it to the, so it's always updating, right? So you take data from here and you use it to update whatever output you have.
Okay.
It's also, it's called the closed system. We will also look, as part of this course, we'll look at it.
Okay.
Some of this, where you take data from the system and then you use it as an output. It's part of this system. When you get to the variable speed limit system, we'll look at that.
All right, thanks.
Okay. So emerging vehicle automation and communication systems. Now we hear of autonomous vehicles, driverless vehicles. Significant efforts are going on, and here is being driven by the automobile industry. If you take all the automobile industries, they have their research groups where they do a lot of research on some of these new technologies. Everyone wants to come up with the best one so that their autonomous vehicle will be the first on the market. And so significant efforts here, and it's being led by the automotive industry, and then the research communities, universities, research institutes where they get funding are also doing a lot of this research. And then government agencies in some jurisdictions where the government is very serious on research, they provide money for some of these things. But mostly as what we are witnessing now is vehicle centric. Most of these things are going on the vehicle. Now, some companies are saying that they fully develop the autonomous vehicles, and the problem here is how to deploy them. Yes, there has been a lot of work on the vehicle, but when it comes to integrating it with the road infrastructure, that is where you have issues, because you should be able to tell a vehicle that at this point, this traffic light at this location will turn red, and so you have to stop when you get to that point. This integration between the vehicle and the the road infrastructure has not developed very much as has been done with the vehicles, as these vehicles technology has been led by the government, by the automobile industry. Okay, so several research are going on in this area. In some jurisdictions, they are looking at, even though they've not deployed autonomous vehicles, but several research are going on as to whether these autonomous vehicles can help increase traffic flow or helps increase efficiency, improve safety, and all those things. So a lot of research are going on in this area, but still, because it's not been fully deployed, there are issues. Different areas of research, safety or the convenience related, and then how to deploy it on urban and then the freeways are all things which are being research into. But as I said, we are not going to dwell much in this course on intelligent transport systems related to the vehicle. All what we are going to do will be this, which is vehicle automation. Sorry, the vehicle automation So vehicle automation and control systems. And this, I'm going to give it to you as an assignment. Here, vehicle automation and control systems can be grouped into two. That is, the ones without direct traffic flow implications, which is here. And then the ones with direct traffic flow implications. So vehicle automation control without direct traffic flow implications. So collision warning and avoidance systems. All these are features in vehicles. I'm sure those of you using modern vehicles, you find some of these features in the vehicles. Collision warning and avoidance system. What is it and what does it do? Lane keeping and then assistance systems. What is it and what does it do? All these are vehicle automatic and control system with direct traffic flow implications. Vision assistance systems. What does it do? Speed monitoring systems. What does this also supposed to do? Driver monitoring systems, other assistance systems, and other warning systems. And then for the vehicle automation and control systems with direct traffic flow implications, here too we can group it into two, urban traffic and then motorway traffic. And here it is necessary to group it into two because all these have different characteristics. When you are driving on an urban road and then on a motorway, the characteristics of travel is quite different. And so it has been grouped into two. Here you have driving assistance system. What is it? Intersection support systems. What is this supposed to do? Then you have the cruise systems, cruise control system, okay, speed regulation system, lane changing or merge assistance systems, combined functionality system, vehicle platooning systems, and then navigation systems. So all these are vehicle automation and control systems. So the first assignment, what you are supposed to do is to tell us or to tell me what these control systems are supposed to do. And then also add it to this. You know, this is technology. Every day a new technology is coming up. And so it's possible that a vehicle manufacturer has come up with a new control system, which is to improve the safety of road users. So if any controls, vehicle automation and control system, you read about it, which is not included in this, please add it. So this is going to be the assignment you are supposed to do as part of this first lecture. And this will be what we will do as far as the vehicle automation and control systems is concerned. So the first assignment, tell me what each of these control system is supposed to do. And then this list I have here, they are not exhaustive. And so you add up to it. If you are using a vehicle, you are using a latest BMV, and then you have any control system which is not listed here, please list it and then tell me what they are and then what they are supposed to achieve in your vehicle. I hope this is clear.
Yes, Doc.
No.
Emanuela, is it clear?
Yes, Doc, it's clear.
Oh, okay. So this is the first assignment. Tell me what each of these automate the control system is supposed to
Hello,
do
sir.
in your
I
vehicle.
didn't get the assignment.
Okay, what I'm saying is that we have vehicle automation and control system. And I have listed some here. I've grouped them into two. The first one is vehicle automation and control system without direct traffic flow implications. And then the second one is vehicle automation and control system with direct traffic flow implications. Okay. And I have listed some of these control systems here. So we have collision warning and avoidance system in vehicles. What does this supposed to do? Or what does it do in your vehicle? If you have this in your vehicle, what does it do? I want you to tell me that. Lane keeping assistance systems, what does it do? Or what is it supposed to do in your vehicle? Speed monitoring systems, what is it supposed to do in your vehicle? That is what the assignment is about. So tell me what all these control systems are supposed to do in a vehicle or in your vehicle. And I've also mentioned that this is technology. It's coming up every day. So it's possible that in your vehicle or as you read vehicle automation and control system, you may come across something which is not listed here. And so include all those ones in this list and tell me what they are supposed to do in a vehicle. Please, is it clear now?
Yes, sir.
Okay. Okay, so this is the first assignment. And this is all what we are going to do on vehicle automation and control systems. As we defined intelligent transport system, we said things in the vehicles, but basically we will be dealing with things concerning the road user and then the road infrastructure. Okay. So if there are no questions, then I'll go ahead. And I'm going to give you an address for a Dropbox where you will send the assignment. And I think you should have the whole of tomorrow to do this assignment. And then the next assignment, now we looked at basic elements of automatic control. So what we are going to look at now is the sensors, which is the methods for automatic data collection methods. And this, I touched on it briefly when we did the traffic flow data collection, the traffic flow modeling course. Yeah, so what I'm going to ask you to do is that's why I was asking the size of the class. I don't want the groups to be too big. And I also don't want to have so many groups. So I expect, let's say, Enoch.
Yes, sir. Yes, Doc.
Enoch, how many people do you usually work with in a group?
5.
5. Okay.
Yeah, 5.
So which means you are going to have around 8 groups.
After it's six persons.
6.
Sorry?
6 persons
We
in
are
a
not
group.
30.
Okay. I think I will take the 5. So 5 people in a group Here you are supposed to also carry out research on automatic data collection methods. I mentioned some of these methods. Let me see. Okay. So loops, radar, Bluetooth, magnetometers. Okay. So you are supposed to do some research on automatic data collection methods, but here too, I don't want you to concentrate on methods like inductive loop detectors. Look at current methods of traffic data collection. Your concentration should be on current methods, like handshake, for instance, using Bluetooth to collect traffic data and all those. So this is where I want your concentration to be. Here there will be a presentation. I'm looking at the number of groups. I'll be looking at 8 minutes. Each group will just use 8 minutes to make a presentation. 8 minutes. And then 2 minutes for questions from the other group. So I will leave the groups to you. All of you should please form the groups, but all the names should be given groups, each groups, and then the names should be given to Enoch, so that I know the people working in the group. And then you come up with this automatic data collection method, the current one. Please don't concentrate on inductive loop detectors. I mean, we know about those ones. Let's concentrate on modern ones. Latest traffic data collection system. This is where our concentration should be. And then we will make this presentation, choose a date, and then make this presentation. But I would want you to use tomorrow. Tomorrow there won't be a lecture. Use tomorrow to do this, and the VAC, the Vehicle Automation and Control Systems. Please use this to do your research on this, and then before we move on to what we will do on Wednesday. Okay. Yes, so if anyone has a question, then please you can bring it along, and then we see what we do.
Please, from Mr. Victor, he said the last time that Wednesdays has been given to traffic demand modeling.
Oh, okay. Okay, so which means that we should have a lecture
on Thursday.
No, we should have a lecture tomorrow.
Thursday, yeah. Oh, okay.
Okay, which means that we'll have the lecture tomorrow. But I would expect you to read the paper I gave you. Okay. I sent you a paper.
Yeah.
Read that paper before we do tomorrow's lecture. Read the paper before we do tomorrow's lecture. And then still, you are supposed to do this group work, research on different data collection methods, current ones, and then we will see. So this is the assignment. And then I would want you to read the paper before we do this tomorrow.
Doc.
Yes.
I thought you said tomorrow there wouldn't be lectures.
What Enoch is saying is that Wednesday there won't be lectures, which means that we can't lose tomorrow and then Wednesday. So tomorrow we'll have to. But I am asking you to try and read the paper. We will start with narratives of what we learned from the paper. So read the paper before we do tomorrow's lecture. Is this clear?
Okay, Doc.
So we are meeting tomorrow, but read the paper I sent to you before we do that. And then the group assignments. There will be a day, I think maybe next week, for you to make those presentations. Okay. Is there any more question?
Hello, doctor.
Yes, let me listen, Samuel.
Yeah, the group assignment. I don't know if the group has been shared because
no, I would want you to form your own groups. I want you to form your own groups.
Okay.
But maximum 5 people in a group. 5 people. 5 people in a group, because I would not want to have more than 8 groups.
Okay.
So I'm looking at
the paper you are sending. Is it with the class of the master student?
It looks like there is an issue here. When I sent a document, it doesn't get to those with PhD.
Yeah.
Yes, most times it doesn't get to PhD students. We have to be asking.
Yeah, Doc. I sent the link to Mrs. Beta.
Beta is not doing this course.
But maybe he's not doing this course, right?
Beta is not doing this course at all.
That's the problem. Okay.
I will send the paper to him. I will take the initiative to send it to him. Samuel.
I can't hear you very well. Who is speaking?
It's Amara.
Yeah, okay. So how does it get to the PhD?
I will send the paper to Samuel.
Ima, do you have it? Do you have the paper?
No, I don't have it.
Oh, okay. So there's an issue here. Maybe I should get one person to deal with, because when I send it to the MSCs, I should also send it to. So who is this? The PhDs, please give me one person so that I send the information to.
You can send to me or maybe someone, any of us.
Okay, so I will send it to Ima or Samuel, and then yes, so I will forward it to you now. I sent it with the presentations the last week, but it didn't get to you. But I would want you to read that paper before we do it. So that is the introduction. I will end it here. Please, the group works. Form the groups. Sometime next week, there will be a presentation from this, and then one other assignment which I will give in the course of the and then try and read this before we meet tomorrow for the lecture. Thank you very much. I think this I'll end here, and then we'll continue tomorrow same time. Bye-bye.